A very good day, dear students. I'm Shomadeep, as you know me, to be your faculty of robotics. Now, in our earlier sessions, we have learned about the introductory part. We have learned about why robotics. We have learned about the brain, that is the microcontroller, why it is needed and what are the functions. We have learned about a very specific thing called the Atmega 328. Now, that was basically the IC with which we are going to work. Now, we are directly not working on the IC. Why I'm saying that? Because the IC is basically fit on the microcontroller board. For example, Arduino, that we are going to use very frequently, okay, for various projects. Now, students, since it was you are doing it for the first time, I gave you an introduction, okay, a read through the Atmega 328. Now, this Atmega 328 is basically the main part of the microcontroller, and it is going to be fit. We can see it on the Arduino board. Now, what is the Arduino board? Let us go into a session in which we are going to study the Arduino board a little bit, okay? And we are going to study the different types of Arduino board that we are going to use for different kind of projects. Let us go into the session. Now, Arduino part 1, the session 5, okay, or the 5th session in our whole course. Now, this is our friendly robot, Max. So let us say hi to Max, and Max will guide us throughout the session. So now let us begin. Now, Max over here has some different parts. You can see the face part or the neck part, right? You can see the body part. You can see the limbs, that are the arms. You can see some happy expression on Max's face, right? All these things controlled by Max's brain, of course. And what is the brain? I have told you earlier, it is the microcontroller, okay, which controls the whole action of the robot. Okay, let us get into it. Let us see the most important thing in the whole robotic session. It's going to be the Arduino board. Okay, so what is Arduino? It is an easy to use open platform to create electronic projects, which we are going to do in further classes. Okay, so it is easy to use, of course, definitely. That's why I have selected Arduino to be the first thing to be taught to you. Okay, we are bringing the Arduino thing, okay, that as the first thing to learn robotics. Why? Because it is definitely the one of the easiest board to use. Okay, understood? All right. Now, the Arduino boards, they play a vital role in creating different projects. Fine. It makes electronics accessible to non-engineers, hobbyists, etc. What do we mean by that? Non-engineers and hobbyists. Basically, many people will be building projects as their hobby, okay, because robotics in itself is very interesting. So you need not to be a full-fledged engineer to build these projects, okay. If you're an engineer, well and good, congratulations, but it's not a very important or definite prerequisite for building these projects. Okay, that's why Arduino is open source. Open source means you can code into it, you can change it, you can change the functionality of it, the base code of it, and you can build any kind of projects, dear students. Okay, now to get into it strictly, let us see the components, the basic components which are present on the Arduino board. Okay, in any Arduino board, okay, these few components are basically present. These few components are common, we can say. I can say in this way that these few components are common in all the Arduino boards. And you must be wondering, sir, what do you mean by all the Arduino boards? All the Arduino boards, by it I mean all types of Arduino. Now, what are the types of Arduino boards? We are going to study in this session, definitely. Okay, so let's get into it. See, the various components present on the Arduino boards are: number one, the microcontroller. By microcontroller, it's the microcontroller board only. By microcontroller, what do I mean? I mean to say the main IC part. What is it for us, for Arduino? Atmega 328. Okay. Then number two comes the digital input or output pins. So basically, what is the difference between digital input and analog input? As I said earlier also, analog inputs are basically continuous set of inputs. Understood? So they are continuous sets. Okay, their value can range from one to another end. Okay, but what is digital? Digital value means either on or off. They work on a binary basis, basically. Okay, on a binary set of principles. Like, for example, you can say either we are giving 5 volts, that is the basic voltage for any component to work, or we are giving 0 volt, that is it is switched off, on, off, high, low, 5 volt, 0 volt. These are the things that you need to remember further. Okay, for the components that we are going to build. Okay, so these are the digital input or output pins. Then comes a USB interface and connector. Okay, it also includes the connector of Arduino to the computer mainframe. Okay, in which we are going to code. Okay, on your laptop or your PC or system. Okay, analog. So as I said, analog means what are the purpose? To get a range of values, various range of values. All right, understood? Okay, then comes the reset. Now, try to understand the situation where you have created a project. I will show you how and where we can use it. Now, you've created the project and you're not satisfied with it. So what you want to do, you want to clear the memory of it. And what you want to do is you want to basically reset it to the previous position, right? Okay, so there comes the reset button. Okay, now after pressing the reset, you again need, I will show you how to do it. After pressing the reset button, you will again need to upload the code and again need to compile and run it. Okay, because resetting means it is basically going into the previous position where you haven't done anything on it. Okay, understood? Okay, that's the reset button. Basically, you all have used the reset function on your mobiles, I think. Okay, that's very common, right? Then obviously comes the power button. Okay, you know what the purpose of the power button is. All right, then comes LEDs. Now, dear students, try to understand LEDs play a very vital role in a microcontroller. They are basically the indicators, you can say. Okay, the perfect term to define an LED will be indicator. Okay, understood? All right, now it can, like the 13 pin, basically I will show you the 13 pin basically in an Arduino board is basically connected to an LED, onboard LED. So either you can like connect an external LED to it to test various components. Like the first thing we will be doing is LED blinking only, don't worry about it. Very interesting and very easy too. That's why I've kept it first. And if you don't have an external LED, no problem. The 13 pin already have an internal LED, onboard LED connected to it. So we can use that also for programming purpose, for seeing, testing the code purpose. Okay. So LEDs basically, they are indicators. We have TX, RX LED also. The transmitter and receiver, that is the TS and RX, I will show you. Okay. So LEDs are basically indicators. Now then comes the crystal oscillator. Now you might be wondering what kind of name it is. Crystal oscillator, what does it do? See, time basically plays a very vital role in any kind of programming. Like, for example, if you take the example of a very simple code, okay, like blinking the LED after 10 seconds, just for example. Okay, so when we are seeing blinking the LED after 10 seconds, you see what we see is after a 10-second gap, the LEDs are blinking, right? Now, who will maintain this 10-second gap? How to give the instruction about this 10-second gap? This was just an example. Okay. So we need, if I want to ask you that, tell me students, at what time you sat for this session and at what time, how much longer the session is going on. What will you do? You will see your watch, or you'll see the wall clock, or you'll see your mobile phones, you'll see your laptops, you'll see your devices, and you will tell me that, sir, this was the time and this was the time. So the session is going this much longer. Okay. So we need timer, right? So basically the crystal oscillator calculates the time. Okay. That's the very basic, very important function. And it is one of the most important uh, property of a crystal oscillator. Okay. And we definitely need it because you will be seeing in our further classes when we'll be coding various codes, we will be including the time, we'll be including the delay over there. Okay, so that is all about the crystal oscillator. Now the voltage regulator, it name only suggests what the purpose of voltage regulator is, to regulate the voltage. Okay, we don't need like the same voltage for everything. Okay, that's a basic purpose. Now let us move into types of Arduino. Now what do we mean? Let me show you this one fully. Now this is the basic structure of an Arduino. This is how an Arduino looks. And if you see here, the long IC over here, this is the Atmega 328 that I was talking about. Okay, this is the Atmega microchip I was talking about. You can see all the pins over here, all the pins, you can count the pins also. I'm giving you the task. So all the pins over here are already connected to the board, and these are the circuit lines, and these pins are basically connected and formed pins over here. See, ARF, that is the reference, then ground, okay, 13, 12, 11, 10, 9, 8, 7, 6. You can see this, okay? And this wave pattern, dear students, can you see a little strike over here, a wave pattern over here? This represents the PWM. See over here, digital PWM. Okay, PWM stands for pulse width modulation, where we modulate basically the width of the pulse, okay? And we set different values. There are the TX, RX. You can see it very clearly. Okay, this is the crystal oscillator. Then comes the USB connector. Then the power supply. Everything is present over here. Very detailed image it is. You can study it. Okay. And as you can see, the name Arduino Uno. This is the primary. This is the most infamous of the Arduino group. Okay, which we are going to use further. So Arduino Uno is based on an Atmega 328P microcontroller. Okay, now it is easy to use compared to other boards such as the Arduino Mega board, etc. Okay, because there are not much functionalities, yet it is very detailed also. Okay, now what else we can see over here? The Arduino Uno includes 6 analog pin inputs. Can you see the analog pin inputs over here? A0, A1, A2, A3, A4, and N5. You can see it is written also analog in, that is analog input. Okay, 14 digital pins. Can you see 14 digital pins? See, from 0 to 13 there are 14 digital pins. Can you see? Okay, can you note it? 14 digital pins. Okay, from 0 to 13. Now this 13th pin is basically also connected to an LED over here. Okay, which is the internal LED, basically onboard LED. You can use it. So 14 digital pins, right? A USB connector, power jack, as you can see over here, from where the electric supply, current supply goes in. Okay, and an ICSP, in circuit serial program. Okay, so that is what this board is all about. Okay, now it is the most used and of standard form from the list of all available Arduino boards. Okay, you everywhere you go, you will be seeing projects based on Arduino Uno. All right, and it is the most common board. We are also going to use it throughout our course, okay, throughout our sessions. It is also recommended for beginners as it is very easy to use. You see the interface, it's very easy to use. Okay, so it is recommended for all the beginners. Now, Arduino Nano, my personal favorite or second favorite, you can say. Okay, this is the second most used. The thing is, its size is smaller than the Arduino Uno. Okay, now see, the Arduino Nano is a small Arduino board based on Atmega 328P or Atmega 628 microcontroller. Now the connectivity is the same as the Arduino Uno. Nothing has changed over here, dear students. Okay, the Nano board is defined as a sustainable, small, consistent, and flexible microcontroller. It is small in size compared to the Uno board. As you can see, I've already told you about it. The devices required to start our projects using the Arduino Nano board are Arduino IDE. That is the place where we will be programming, where we will be coding. Do not worry if you don't know about it. I will tell you each and every instruction I'll give you. I'll teach you how to install it and to work on it. Okay. All right. The mini USB you will be getting it when we are purchasing the Arduino. We'll be getting it from the shop. Now for our further projects, you can buy Arduino Nano or Arduino Uno, whatever suits you. I would prefer you can buy both of them, okay, and you can practice on them first in Arduino Nano and in Arduino Uno, okay, or any of them would work. Do not worry about it. The Arduino Nano includes an IO, that is input output pin set of 14 digital pins and 8 analog pins. It also includes 6 power pins and 2 reset pins. Okay. So the size is very small. It's very handy. You can fit it anywhere. Now, Arduino Mega, as the name suggests, okay, it's a bit more complicated. A bit. Okay. Do not worry about it. Not much. So it is based upon Atmega 2560 microcontroller, okay, or microchip. The Atmega 2560 is an 8-bit microcontroller, as the earlier ones. We need a simple USB cable to connect to the computer and the AC to DC adapter or battery to get started with it. Okay. It has the advantage of working with more memory space. That's why it's a bit heavier, right? By heavier, what do I mean? Not by weight. Okay. By heavier, I means the workload on it. Okay. It works with more memory, more space, okay, more storage space. The Arduino Mega includes 54 input output digital pins and 16 analog pins or input output analog pins. ICSP header, I have told you what it is. A reset button, as you can see over here. 4 UART, that is universal asynchronous receiver or transmitter, that is TSRX, but we denote it in UNO. Okay. USB connection and a power jack. Okay, so when you are you've got a hand of it, you have got like command on Arduino, then you can buy it and you can use it for heavier projects or bigger projects. Then comes Arduino Micro. Okay, even smaller. The Arduino Micro is based on the Atmega 2U4 microcontroller. It consists of 20 set of pins. Okay, the 7 pins from the set are PWM, that is pulse width modulation pins, while 12 pins are analog pin outputs. Okay, the other components on the board are the reset button, because we need reset button is very like basic to all the Arduino board, because it is very much required. You will see when you will be hands-on, you'll be performing the hands-on project. Okay, you will be seeing reset button is very useful, a handy button. Okay, you don't need to like do all lot of things. Just press the reset button and it will be resetting to the previous mode, and you can code it again. Okay, or upload it again, compile it again. Okay, so done it again. And then comes the 16 megahertz crystal oscillator. Okay, so crystal oscillator is basically the timer, calculates the time, ICSP header, and a micro USB connection. The USB is inbuilt in the Arduino micro board. Okay, the Arduino micro is also called the shrunk version of Arduino Leonardo. Now, what if you're wondering like what do we mean by the Leonardo board? So here it is. Okay, the basic specification for the Arduino Leonardo is the same as the Arduino Micro. It is also based on Atmega 32U4 microcontroller. The components present on the board are 20 analog pins and the digital pins, reset button, 16 megahertz crystal oscillator, ICSP header, and a micro USB connection. So basically, it is the minimized version. The micro is minimized version for the Leonardo board. All right. I hope you've understood that. Okay, the Arduino Duo. The Duo is based on the 32-bit ARM core, okay, a bit heavier. All right, so it is the first Arduino board that has developed based on the ARM microcontroller. It consists of 54 digital input-output pins and 12 analog pins. The microcontroller present on the board is the Atmel SAM3X8E ARM Cortex M3 CPU. Okay, a bit heavier on the side. So you see, what are the specifications? So how the Arduino boards are being divided among themselves? Basically, they're about the size. By size, what do I mean? Not the size of the board. Of course, if you increase the pin number, the size of the board is gonna increase. Of course, like very basic. But the thing is, our main motto is to make it a better version of it, like so that a heavier code can run. See, all our life we are not going to do the basic projects, right? The basic projects are just to learn. Now when we do a real-time projects or real-time function, then we need something that's going to run the heavier loads, or that going to have a greater memory, a bigger memory. All right, so that is how the specifications are being done over here. Okay, now it has two ports, namely native USB port and programming port. Okay, these are the two basic ports that we need in a controller, one for the connection and uploading of the code, and the other for the power cable. The micro side of the USB cable should be attached to the programming port. All right. Then comes Arduino LilyPad. Now this one is a very beautiful one. I worked with it. Now why I'm saying this one is a very handy one also, because these are for the portable projects they were designed. Okay, if you see, if you buy it from the shop, you'll be seeing the size, the everything fits. Okay, the Arduino LilyPad was initially created for the wearable projects. All right, portable arm, okay, movable arm, these kinds of projects, the LilyPad is being used. Okay, and e-textiles. It is based on the Atmega 168 microcontroller. The functionality of LilyPad is the same as other Arduino boards, but it is round in shape. Okay, lightweight, very lightweight. You will be seeing if you purchase it. It's very beautiful to work with. Okay, very handy to work with. Lightweight board with a minimal number of components to keep the size of the board very small. Okay, whatever components could have been omitted, they are omitted from this board, so that size of it becomes very small, like to the most smaller size possible, smallest size possible, and to keep it very lightweight. Okay, the Arduino LilyPad board was designed by SparkFun and Leah. It was developed by Leah Buckley. It has 9 digital IO pins. Okay, so it's not for very heavy load projects or bigger projects. All right, I'll show you. So don't worry, I'll show you where it can be used during our course. Then comes Arduino Bluetooth. So the Arduino Bluetooth board, you can see it's written as Arduino BT for Bluetooth, is based on Atmega 168 microcontroller. It is also named as Arduino BT board, as we see. The components present on the board are 16 digital pins, 6 analog pins, reset button, 16 megahertz crystal oscillator, ICSP header, and screw terminals. Okay. The screw terminals, why they are added? The screw terminals are basically used for power. Okay. You can as you can see, motor shields, if you might have seen, or motor boards, you can see by the screw terminals, the power wires, the live wires can be connected or tightened, fitted on it. Okay, for power purposes. The same way this also works. The Arduino Bluetooth microcontroller board can be programmed over the Bluetooth as a wireless connection. So that is the most advantageous thing that we have in BT, that is Arduino Bluetooth. You can just connect it to the laptop. Okay, you don't need a wire. So the issue or the problem for the which occurs due to the breakage of wire or anything like that gets resolved by this board. Okay, we are basically problem solving materials we need, right? Every problem we need a solution for it. We can design a solution for it. So the solution for that wire thing and everything, the portable jack thing, we have designed a solution, that is the Arduino Bluetooth connection. Okay, so by Bluetooth you can connect this board with the laptop and you can program it. Fantastic. Let us move further. Arduino Disimila. Now Disimila is also based on Atmega 628 microcontroller. The board consists of 6 analog pins. That is the 6 analog input pins, 14 digital input output pins, a USB connector, a power jack, an ICSP, that is in-circuit serial programming header, okay, and a reset button. See, reset button is present everywhere because it's needed, okay. Trust me, you'll be seeing when you are doing the hands-on project, it will be needed again and again, okay. All right. So it can power on the board with the help of AC to DC adapter. Okay, we will be needing an adapter for this one. The Disimila was initially developed to mark the 10,000 delivered boards of Arduino. Okay, so Arduino became famous very quickly because it was very handy to use, as you see. Okay, and as to honor the 10,000 supply of Arduino, we have designed the 10,000. That is the board. That is the Disimila board. Here, Disimila means 10,000 in Italian. Okay, that's how it got its name. Now, Arduino robot. Can you see the structure? Just look at the structure and you'll be seeing how heavier it is. Like it's basically fitted with the wheels on it. Okay. It is called as a tiny computer. It is widely used in robotics. Why? The board comprises of the speaker, 5 buttons, color screen, 2 motors, an SD card reader, a digital compass, 2 potentiometers, and 5 floor sensors. So you see all the sensors fitted at one, okay, basically designed in one Arduino board. Okay, that is why it is called an Arduino full-fledged robot in itself. Okay, very useful. It's a bit costly also. As you can see, all the parts are being fitted over here. Okay, the robot library can be used to control the actuators and the sensors. Okay, it also has a screen on it, so you can basically calibrate and you can basically give values to it. All right, I hope you understand what I'm trying to say. Then comes Arduino Ethernet. Now, what is it? You can see the board, the structure of the board basically a bit different. The Arduino Ethernet is based on the Atmega 328 microcontroller that we are studying from the beginning. The board consists of 6 analog pins, 14 digital I/O, that is input output pins, crystal oscillator, reset button, ICSP header, a power jack, and an RJ45 connection. All right. With the help of the Ethernet shield, we can connect our Arduino board to the internet. Okay, we have the Ethernet shield, we have the motor shield. We'll be working with it once we are done with this session. Then comes Arduino Zero. Okay, the Arduino Zero is generally called the 32-bit extension of the Arduino Uno. Okay, so it's basically a bigger size, a pro size, okay, of the Arduino Uno. All right, it is based on Atmel's SAM21 MCU. The board consists of 6 analog pins, that is the input pins, 6 analog input pins, 14 digital input output pins, a USB connector, a power jack, and an ICSP header, UART port pins, a power header, and ARF button, that is the reference button. You might be seeing something over here, which I don't think you have noticed, that whenever we are talking about analog pins, dear students, we are saying 6 analog input pins. But when we are talking about digital pins, can you see we are seeing 14 digital input or output pins? What does that mean? That basically means that in analog form, we can give the input to it, whereas in the digital form, we can give the input to it and also take the output from it. Understood? All right. Okay. The embedded debugger of Atmel is also supported by the Arduino Zero. The function of debugger is to provide a full debug interface which does not require additional hardware. Understood? Okay, I hope it is clear to you. Let us move further. Arduino Explorer. The Arduino Explorer boards allow easy interfacing of sensors and actuators. It's a very small in size, as you can see. The outputs and inputs connected on the Explorer board make it unique from other types of Arduino boards. How? The board includes outputs, inputs, a small microcontroller, of course, a microphone, a sensor, a joystick, an accelerometer, a temperature sensors, 4 buttons, and a slider. So can you see somewhat similar to Arduino robot? We can say there are many functions of it. Okay, it has a microphone sensor. So what we generally do is when we are working on the simple projects or the basic projects, we buy the sensors, we purchase the sensors from the market, from the shops. Okay, and we buy an Arduino board and we like continue the working on the projects by fitting those sensors to the Arduino board. Now, some Arduino boards, such as Arduino robot specifically, okay, it's not for the beginners. And this Arduino Explorer, basically, you see many sensors are already placed in it, right? So it becomes a bit easier if we perform those kind of operations. Okay, understood? Next, Arduino Pro Micro. The structure of Arduino Pro Micro is similar to the Arduino mini board, except the microcontroller Atmega 32U4. Okay, the microcontroller is changed. The board consists of 12 digital input output pins, 5 PWM, that is pulse width modulator pins, okay, TXRS serial connections, and 10-bit ADC. That is ADC means analog to digital converter, ADC. Okay, understood? All right. Now, so we have studied a whole bunch of Arduino boards. Those were important. And if you see this picture is basically what I've done is I've taken a screenshot directly from the Arduino IDE so that the real time thing is visible to you. Can you see Arduino boards written over here? And we have a down arrow over here. If we click on it, more boards will appear. So Arduino have a whole lot of boards present in its IDE only. So whenever you are like uploading a coding or programming in the Arduino interface IDE, so you'll be getting an option to select the board. Basically, what we do is we generally, when learning robotics, we select Arduino Uno. That is selected already over here. You can see I have selected it because I was working on it. Okay, Arduino Nano also, Arduino Mega is there. Everything you can work on any of the board. But the thing is, for the beginners, I will suggest to only select Arduino Uno or Nano. Okay, basically Uno is the first preference. Okay, these are some of the other names that you can just have a look out for it. Okay, no need to remember the names or anything like that. All right, dear students, so this is it. Okay, this is it. I hope you have enjoyed the session. We have studied a more amount of Arduino boards. More to come in the further session. We'll be seeing the architecture of the Arduino board in details, and the most important thing, we'll be getting started on with the programming part, the software part basically of Arduino, and we'll be starting building projects soon. Okay, so I hope you have enjoyed the session. Thank you very much for your patience. So we'll be definitely meeting upon in our next session. Till then, bye bye. See you all.